Hi, I'm Nick Fitzsimmons, and I'm the project manager for Team 3, the Wire Wizards, working on the cable auto tie-in.
Hi, my name is Brian Ferris, and I am the logistics manager.
Hi, I'm Nathaniel Freilich. I'm the safety coordinator and manufacturing engineer.
Hi, I'm Huaxin Liu. I'm test engineer.
Hello, my name is Sawyer Woodland and I'm the financial manager.
Our client for this project has been Harbour Industry, based out of Shelburne, Vermont. They're a manufacturer of high-performance wire and cable for the aerospace, military, industrial, and manufacturing industries.
Harbour Industry's goal in this project is to automate the joining of a copper tagline to the end of a silver-plated copper wire after a process coats that wire in a PTFE installation. Currently, that tie-in is done by an operator manually. There is a risk to that in terms of the operator's safety for getting caught in the wire and in the join, and it also requires that the wire be slowed down significantly in order for the operator to be able to handle it.
Our client has a number of requirements for this project to be successful. First, it must be safe and have no pinch points, along with sufficient guarding to protect the operators. It must be ergonomic and user-friendly, while also being compact, fitting in the limited space available in the production line. Further, it has to operate at a speed greater than 125 feet per minute and be able to join a variety of wire gauges from 14 all the way up above 22 gauge wire. It should be precise, able to repeatedly make the wire tie-in, while also avoiding contact with the wire until the insulation runs out and it's time to make the join.
We considered several design options when working on this project. It started off with crimping, but we couldn't use that because it used consumables. Next, we moved to ultrasonic welding, which are extremely expensive, so we weren't able to use those. Next, we moved into twisting the silver around the copper wire, which didn't quite have the strength necessary to be viable. So next, we moved into several different types of knots. So the knots we looked at were figure 8 and square knots, but those were too complicated to make with our design. For our final step, we looked at a slip-knotted tagline with a twisted silver loop.
This project used a number of technical skills, methods, and analyses, including machine tools,
SolidWorks,
For our circuit design, we use OrCAD Capture, and then OrCAD Capture is transferred into PCB Editor, where the board layout is performed. And when you're all done, you get one of these.
For software design, we use Arduino.
and lots of Allen wrenches.
So you can see here at the beginning of our process, the accumulator. So the accumulator creates slack, and you can see right there it's actuating downwards, creating the slack, followed by the push solenoid directly to the right of it. That push solenoid pins the wire in place, while then the accumulator slowly comes up, being pulled by the wire to the left of it. Next, you can see our joiner spinning. So that's a two-part mechanism. First, it pulls down and then it spins, creating the wire. And lastly, you can see our cutter cutting there to separate the silver wire. And now you can see the knot traveling down the line, connecting the silver and copper wires.
As far as what's next for our project, we'll be handing it off to Harbour Industries, where they can evaluate it themselves, determine if any improvements or design changes need to be made, and hopefully implement it on their production line. For this project, we'd like to acknowledge Bill Gagnon, the engineering manager at Harbour Industries, who's been our main contact and liaison during this whole process. We'd like to acknowledge Donald Leclerc, the director of manufacturing at Harbour, along with Dustin Rand, our mentor and seat advisor and the director of this program, who made all this possible. And lastly, Karen Bernard, who has handled all of our purchasing and returns throughout this whole process.